Well, I hope you can all hear me.
Yeah.
Yep, excellent. Helicoptered in at short notice. Always happy to help out. I believe there's a speaker dropped out, and I got the message, could you do a talk? You're sponsoring it anyway, as Mary Metso. And I went, yeah, sure, of course. I'm always happy to stand up in front of a crowd of people and make a complete fool of myself. It's absolutely fine. However, I did get back from a trip yesterday, very late at night, and had some stuff to do this morning, fell asleep, woke up at 2:30, and then went, oh, I've got to write a talk, haven't I? So here we are. This is the production of about 2.5 hours work. So it's going to start, yay, it's going to be great, trust me. What we're going to be looking at, the title that I provided for the 1905 group was Pentesting Demystified, because I didn't really know what to call it. And I deal with a lot of APIs, and I deal with a lot of juniors and other pen testers, even experienced pen testers, who are facing an API as opposed to a web application or any other kind of test. And they're kind of like, what is it? What does it mean? So what I've decided to do today is more of an API 101. So it's going to be basic. It's going to be quick. I hope this isn't going to take more than about 30 minutes of your time. We're going to look at some basic kind of web concepts. We look at how APIs have developed and some of our strategies for actually, how do we assess them? How do we assure them? How do we actually look for bugs and vulnerabilities? So we're going to fly through it. Just so you know, I'm Campbell Murray. I'm Chief Operating Officer at Mary Metso. That's my Twitter link. Follow it if you want. There's not much security on there. It's mostly sailings, dogs, and drunken ramblings. So feel free to get stuck in. As I say, lots of dogs on my Twitter feed. Many, many. So why this talk? Well, I've trained and developed and mentored many, many teams over the last kind of, I don't know, 25 odd years. And where we generally start juniors with is like some pretty basic web application hacking. We get them hooked into things like proxies, Z-Attack proxy, Burp Suite, in the old days, Paros, sometimes Charles, different Java-based proxies. And I go, yeah, you're doing really great. You're doing really great. Oh, by the way, the test you're doing next week has got an API. I don't know how to do that. I was like, yes, you do. It's just an API. I go, well, what do I do? Okay, well, here's some basics. That's what I'm literally going to cover with you today, is what is an API? How do we hook into it? How do we use our standard methodology for things like HTTP testing? And how do we apply that to what an API is? We're not going to go super in depth on technology. We'll look at some strategies. Speaking about web servers, there's a key difference between APIs and your average website. Now, the Hypertext Transfer Protocol was defined in RFC 2616 sometime around the mid-70s. Someone will probably correct me if I'm wrong on that. It's been around for a long, long time. HTTP, obviously developed by Tim Berners-Lee and used as a standard for Hypertext Transfer Protocol. That's moving HTML or other text from one server to a client and rendering it, and also being able to send messages from your web browser. They didn't actually used to be called web browsers, but whatever client you were using back to the server to elicit a response. It's very, very well defined. W3 School or W3 Standard School, all of the protocols are set out, and they're quite familiar to anyone who's done any kind of application penetration testing. We've got options for web servers like get, post, put, delete. There are others, there's trace, debug, and a couple of others, and they are well understood. They are standardized. They're almost an ANSI standard, not a full ANSI standard, but they're approaching it. And every web application server that you encounter, be that Apache, Windows, any other various variations of them, including things like Python stand-up servers and Ruby stand-up servers, if you're into coding, they all understand the same set of commands and options. So to demonstrate this is a very simple GET request that I did earlier today. I'm using the ubiquitous tool of Netcat, because everything is Netcat all the way down. If you look at any bit of internet technology, it's basically Netcat with a wrapper around it. So we're using Netcat here to connect to my local host, where I've stood up a simple Python server, and we receive common responses. We get the server type, we get the date, we get some content type, headers, content length. It's all standard. One of the key things to take away from this is the actual request. We're asking to get slash over the protocol HTTP 1.0. Now, the slash is a key element in HTTP standard, in that it says, give me the index file of the web server. Whatever that web server is configured to, typically it's index.html, HTML, index.php, normally called index, convention, there's no rule around it. Could be bob.htm, it doesn't matter, it's whatever you set the server to, but the server will understand what you are asking of it. And this is a key concept in all web servers. We get some HTML output, and your web browser will render that. This is just displaying the contents of a directory on my local laptop. So it's pretty simple stuff, and it's well known and well documented. When we're testing websites, there are common techniques we can use. We get slash, we get an index page. We can use tools that we have to spider the links, go and look around the site, figure out what the sitemap looks like. We might grab the robots.txt file, which is fantastic from a security point of view, because this is all the things we don't want search engines to look like. So of course, we're not going to look at that, are we? That's all the interesting stuff. We can brute force directories with response codes in HTTP servers. 200 means, okay, that file's fine. Here's a file. Here's some HTML. 404, should know that. That doesn't exist. So by brute forcing directories, just by trying different file names, we can find 200s and 404s. We can build a list of all the assets that are on the site. Super simple stuff. Google modifiers like cite are fantastic because they often hold historical records of stuff that's been indexed that's no longer or now forbidden to be indexed in the robots.txt file. So we can find old stuff in websites. We go, are you still there? Hey, cool. It's really good. We can use typical techniques like input fuzzing, very, very common, lots of tools for that. We're trying SQL injections or SQL, depending which side of the fence you sit on, cross-site scripting, get and post requests. But it's easy to do because when you look at a website, everything's there in front of you. The website literally advertises to you what it is you want to test. Things like forms. So here's a very simple HTML form request. The form in HTML, this is sent to your browser, rendered, and you might have a login form or a contact form. And it says the method is get. Well, that just means that it's going to put it in the query string. Cool. If it was post, it means the sent as headers. This is super simple stuff. But it's advertised. Our input type is the type of text, and its name is fname, and the next one is lname. So if I submit that form, I end up with a URL that looks a bit like this. Go fname equals input, lname equals input 2. And then I can start doing my SQL injection, my cross-site scripting, my fuzzing, path traversal, code injection, all those really, really good attacks. But it's easy to start these attacks. But in a website, bang, it's there. It literally advertises to you where your inputs are. HTTP also supports lots of other languages as well. It's not just HTML. We've got pre-hypertext processors. We've got active server pages. We've got different types of compiled at runtime, compiled before into binaries, processed on the fly, like pre-hypertext protocol is. And it's also important to know that HTTP is stateless, but we'll talk about that in the context of API slightly later. Now, this is an example of PHP code. This is what we would call spaghetti code. So it's a PHP file, is executed on the web server as a HTML file. The PHP is processed by a different part of the LAMP stack, the Linux Apache MySQL PHP stack, and that generates HTML for you. So some very simple programming logic there, set some variables, and we write them back to the page that come out as HTML, but we're embedding programming languages into our actual surface web files. And testing websites is pretty straightforward because, as I say, the website advertises everything you want, everything you want to look at. So what's an API? It stands for Application Programming Interface. Predominantly, it's used to allow two applications to talk to each other. So when we talk to Google or another search engine, we say, find me a local restaurant. And it says, okay. And it gives you a whole bunch of HTML. That's rendered in the browser. And that's a lot of content. Not so good if there's a business service over there that says, Google, show me all the restaurants in this area, this postcode. It goes, here's a load of HTML. You go, well, I don't want that. I've now got to process that. It has a resource cost. It's difficult. Just send me the data in a simpler form. And that's where APIs come in. That's what they really do. They're really lightweight compared to HTTP. They're a lot faster, and they are increasingly created. They are a large, large part of the web. They are an unseen part of the web, but they are so prevalent now that pretty much, I've been pen testing for way longer than I'm prepared to admit. And I think now we probably do somewhere around 60 to 65% is API testing versus when we're doing web stuff, about 65%. I think about that. Sounds about right, feels about right. And the rest is HTTP. So they're a huge part of the web today. So we really do encounter these on a very regular basis. Some examples of APIs, flight information, aggregation of data. You want to search for what's it called, Skyscanner or Flight Scanner or whatever the website's called, that aggregates data from loads of different sources, travel agents, companies, whatever. It's not asking for a HTML page. It's getting its information over API calls, which are much, much lighter weight and easier to process. Things like hotel room availability. If you use commercial services, they'll find me a room. I'm stuck in Prague. I've missed my flight. No, I'm saying it's never happened to me, but I'm sure it has probably happened to a few people here at least once. And you go, I need a hotel, and it's 3 in the morning, and I've lost my shoes. And your app on your phone is aggregating data from APIs. Stock prices, tickers, constant updates. You couldn't do that with full fat HTTP requests. It would put too much load, and it's an inelegant solution to a fairly simple problem. Different types of APIs. You can find open APIs. There are many of those around, like flights. Partner APIs. Now, they're the ones that we generally pen test. We're like, I'm company A, and we are pulling supplier data down the supply chain from someone else. We want to make sure no one else can see that or interfere with it, tamper with it, change it, do anything to it. And that could be the focus of the test, the scenario and the test is based. And then you may have very private APIs, which is your mobile phone to your bank. And that's it. There are 3 different classes that they loosely fall into. Of course, many of them cross different boundaries. Nothing's ever simple. But as I said, we're flying through this at about 700 miles an hour. There are some standards around APIs, and I'm not getting into these, not in this talk. REST, Atom, SOAP are 3 very common ones. Well, Atom less so these days, but it's not important. There are lots of others. There are around 1,000 standards for APIs in terms of communication protocols. We're not really concerned when we're pen testing what the protocol is. Oh, you're testing a REST API, right? You know, makes no difference. It really doesn't. It doesn't matter if it's SOAP. It actually makes no difference to our methodology. They're purely used to data transfer where that full communication is inappropriate or inelegant or unreliable, or puts too much load on systems. And bear in mind, all commerce is about pounds at the bottom line. So if we can get away with smaller servers that use less electricity and cost us less, we're going to make an API. JSON is a very common data transfer standard. And again, we're not going to get into it in a big way. It's lightweight. It's slightly more preferable on APIs than XML, which is a little bit chunkier. So we use JSON because it's nice and slim. And here's a good example. Oops, hello, I've gone the wrong way. Here's a good example of JSON. So I don't know if you can see that. There's a JSON description of a donut. So the type is donut, the name is cake. We've got some of the different batter options and some topping options. And this is pretty much what JSON data looks like. It's very simple. It can be parsed by all languages. It's not a full ANSI standard, but it's almost an ANSI standard, just like structured query language. It's understood and ingestible and interpretable by whatever you're coding in, by PHP, ASP, Java, whatever you're writing. They can all invoke a library that understands this and pass it and do something with it. So it's simple and it's common. And it's easy to read. If you're debugging your code, it's fairly straightforward to understand. But where an API differs, really differs, is that unlike a HTML file, a HTTP server, those variable names that you're going to be looking for are not advertised. If you don't know what they are, you don't know what they are. There's no web page that goes, oh, these are all my form values and my different types of data that you can start fuzzing at me. With an API, you're kind of starting blind, unless somebody's got the magic cookbook to provide to you. And this is where a lot of junior pen testers just go, I don't know what to do. Where do I go from here? Because they have nowhere to start. But with API testing, it is really, really simple. Variable names, option names. It is common in APIs to use get, post, put, delete, to use those conventions, but there is no rule to it. Those server options could be whatever you want them to be. And if you make them very obfuscated, you can make them really long and complicated, randomly built strings to really mess up anybody trying to talk to your API. You don't have the magic cookbook of how to actually communicate with this thing, you're pretty stuck. And this adds layers of security. It's security through obscurity. There's no difference in the way the data is transferred. It's still netcat at the end of the day. It's all netcat all the way down. So let's have a look at an API call a little bit more closely. Now here's a sample one in curl or curl. I don't mind which way you pronounce it, but the correct way is curl. And we're suggesting that we use a get request. Now with an API, that could be anything. It doesn't have to be get, but in this example, it is. We have 3 different areas that we're concerned with. Host, root folder, too many shadows, the API name, the class, and what we call the API endpoint, which is the end part before you start sending variable values. Now that API endpoint can be called whatever you want. These variables, here we've got trust ID from with some date ranges, to with some date ranges and a status. But those variables could be whatever you want them to be. And the API does not advertise them, unlike a website, right? So when testing APIs, you're a bit kind of like, okay, right, well, if the devs aren't going to help me and give me some files to tell me what it is I'm doing, I'm a little bit stuck. But it does look very familiar. This is the problem for pen testers, especially those unfamiliar with APIs. There's no get slash in an API, typically. Oh, just tell me everything. And they go, oh, here's the index file, and you can go from there. That's not what APIs are. Remember, security through obscurity. You can't spider an API. You could brute force it, but you can't spider it. You can't get the front page of the website and say, follow all the links, and then catalog all the input variables in all of those pages. That's the whole point of an API. If you don't know the variable names, you're a bit stuck, you know? So you can brute force them, or someone can give them to you. So this is introducing a tool called Postman, which is very, very common in API development and testing. There are others, but I say, skimming through this at 700 miles an hour like a jet plane. It's a tool for API testing. It is not a security tool, but it is a GUI tool that will allow you to ingest API formats and send and receive test data. You can automate some UAT type testing to make sure that it's doing what you think it is, but it's not going to start fuzzing variables or looking for vulnerabilities for you, unless you pay them a lot of money. I think there's got some modules in there. I've never used the full fat version of Postman, but I can't imagine it's any better than the other tools we've got in pen testing. So if the client can provide either Postman or Swagger, which is another format file, can both be ingested into Postman, and we can use those for API testing. Otherwise, you're poking in the dark, literally. You don't know, and that API is not going to give you anything. This is a screen example of Postman, where I've been given, I believe in this example, Postman files rather than Swagger. I've ingested them, I've imported them, and they've given me some cool stuff here. I've got the API name, I've got the classes down the side, I've got all the API endpoints, and I've got the variables. Now, I could spend a lot of time changing all of those, going single quote, double quote, at version, you know, and do sleep, all the different kind of SQL injection vulnerabilities, and start fuzzing it manually. That's going to take a very, very long time. So we proxy it. We can use a tool like Postman to proxy it into a familiar website testing tool like either Burp Suite Professional, Z-Attack Proxy. There are many, many others out there. I am vendor agnostic, but honestly, I'm in a bit of a debate at the moment about which is better at the moment, Z-Attack Proxy or Burp Suite Professional, because they're kind of, yeah, it's like that, I don't know, that Disney film Cars race at the end. They're getting very, very close. But we still can't spider an API. Even if we proxy something like Postman into Burp Suite, we have to go and invoke every single call and click manually through all of them so that they register, and Burp Suite or Zap can see those API calls, can see those endpoints. Once we've got them all in there, then we can hit active scan. I'll go for a cup of tea now. Postman has a really nice feature where you can grab the curl strings as well, which is fantastic because this gives us the curl requests nicely translated from whatever it is, whatever language Postman speaks, into something we can use at a Linux command line or in Windows command line if that's your favorite. Once we've got those, we can use curl to add local proxy commands. As we've got here, I know you can't see that, it's it's quite small, to run the curl command. And here I'm trying a Google account client login via Burp Suite. Didn't work because on this occasion, as I say, I did this afternoon, for some reason curl wouldn't ingest the Burp Suite certificate. but you can see that it's actually given an attempt, and that URL appeared in Burp Suite. Right now, I'm into a website testing methodology because I'm building my asset list. It's fairly straightforward. So once you've got all your API calls, you can do everything that you would normally do with a website. You can do your active scanning, which will find the variables in the string and substitute them out for different. We're looking for cross-site scripting, SQL injection, path traversal, all the good stuff. You can add it into intruder, repeater, whatever you're doing. Yeah. Still looking for the same things in APIs as we are in websites. The difficulty is getting over the hump of getting it into an environment where you can actually start throwing stuff at it and start making some progress and saving some time. We're still looking for SQL injection. We're still looking for cross-site scripting, path traversal, all the OWASP top 10, all of those. Every kind of web application vulnerability can still exist in an API. They are not immune from them. Their great security feature is that they are by obscurity. They have a layer of obfuscation that you have to get over. And that's the big hump with noobs, with 101 API pen testing, is having that understanding of how they actually work, what the difference is. If we don't get the Swagger files, though, what do we do? Customer says it's totally black box test. Sorry, I'm not giving you anything. You've got a, here's the class for the API. It's up to you now. I'm not going to tell you any endpoints. Where do you go from there? Yeah, pretty difficult. You're kind of looking in the dark. But we can create very, very simple fuzzers with a few lines of code as well. So here's one I actually created for an API test. I had a charming customer who told me that, no, you're on your own. Tell us what a real attacker could do. So in, what is that, 5 lines of shell code, I've created a fuzz text file, and I'm just importing sorry, there's a line numbers on the left. I forgot to take them out. Created a huge word list of hundreds and hundreds of thousands of words and ran it through basically curl. And just trying every possible name, see if we found something that sticks. And it's just pure brute forcing and pure luck. The results of that didn't go well because I didn't get any results. It was all 404 not found. So despite not being a HTTP server, we still get the same kind of server responses. We get 200 good, 404 not found, and all the other varieties of 302 redirects are all in there. In this case, I went through, I don't know, something like 900,000 different words that were just randomly generated, and I didn't find a single one that stuck. Not a single one. Okay, fair enough. You win this time, client, but I'll be back. And that's what we're going to do. But something that HTTP and API interfaces share is that they're both stateless. And this is a concept that if you request a web page, and in the early days of the design of HTTP services and the web, content persistence was never really considered in the standards. And the story I've been told recently, and I don't know if it's true, so please tell me if this is absolute rubbish, that Tim Berners-Lee decided to design the World Wide Web because he was working in one building on campus on the top floor, and one of his co-workers who was doing a project with worked on the you see what I think about work, worked on the top floor of a building on the other side of the campus, and he literally just got fed up going all the way down the stairs, all the way up the stairs going, can I have that piece of paper? And all the way back again. So they designed a mechanism of communicating simple plain text between them. And that was the kind of origin of the hypertext transfer protocol. There was no state. Now today in modern state, you're looking at things like session cookies. Are you logged in? Are you logged out? What's in your shopping basket? How do I identify you or you or you if you're all looking at a website at the same time? Yeah. So HTTP and APIs are both by nature stateless. They have the same origin. So APIs are generally non-interactive as well. There's a request response only, just like HTTP. So there has to be a way of tracking you. Now, with an API, it's a one-shot wonder. It's tell me what flights are leaving Dallas at 5:30 on Thursday. Bang, you get some JSON data back. Your backend processes it, shows it on your app, shows it on your website, whatever you're doing. How do we authenticate you? Now, in APIs, the common concept is the OAuth 2.0 standard called the bearer access token. Now, this, if we're testing websites, things like Burp Suite, Z-Attack Proxy, they will maintain cookies for you. They will maintain all of those states for you and keep you logged in over a long period of time. But with APIs, not so much. You have to authenticate to the API, gain a bearer access token, and you have to supply that with every API test you do, whether that's through Burp Suite, shell script, however you're doing it. And it has a limited time. This is something I've seen newbies fall down on a lot with API testing. After 20 minutes or 40 minutes, whatever the timeout is set to, they just go, oh, it's not working anymore, I've broken it. No, you need a new bearer access, just get another bearer access token and start again. So it's something we need to be aware of when we're testing. It is part of the OAuth 2.0 standard. Other standards are available. There we go. So the bearer token times out. It's just an added complication, but again, something that's not often, because we're so used to testing websites, and we tend to have a habit of starting juniors on, here's a simple website, or here's a website with some form input. We're going to teach you how to fuzz. We're going to teach you some SQL injection. API is just a little bit more complicated, and they throw up those security barriers to us. If we're not aware of them, we can fall foul in our basic methodology. So in conclusion, APIs are nothing to be scared of. They are simply stripped down lightweight web servers, basically, in concept. We can mostly use the same tools we use for websites if we understand how to load them into those tools and what the limitations are with how long we've got for sessions, bearer access tokens, rate limiting, anti-automation techniques. If you hit active scan in Burp Suite on an API, it'll probably tell you, if it's a good API, it'll tell you get lost very, very quickly. So we need to know how to tune how to throttle our activity as well. It's just HTTP with extra steps, basically. And that, I believe, concludes Noob 101 API testing. So if there's any questions, Dave's left. No, Dave's over there. You can ask him. Thank you.